Alright, good evening. Welcome to
FamilyMath182a.
FamilyMath182a. So we saw this really neat problem in our Art of Problem Solving geometry book this morning, and we're just going to talk about it one more time. And then after that, I'm going to show you a couple really cool theorems from our Geometry Revisited book, which is somewhere. I'll get it for the next movie. So the problem is this. You have an equilateral triangle, and you put squares on the sides of the equilateral triangle. And then it said prove that when you connect up these opposite corners of the squares, that you get an
equilateral triangle.
Okay, and how do we prove this? What did we do?
Well, we want to prove that these sides are the same.
Okay, to show something's an equilateral triangle, it's sufficient to show that the sides are the same. Okay, good.
So we can draw this line here.
All right, draw this line out. I didn't think to ink. Okay, there's one.
And then there's this line.
Okay. This line across here, which comes down like, whoops, not my ruler, but that's alright. I'll just try to make it straight as I can. Okay, comes down there.
And this line.
This time I'll just freehand draw that. Okay, and what are we trying to show now?
That we need to show that the triangles are congruent.
Which triangles?
The triangles that we just drew. This one here.
Okay.
These three skinny ones.
These three skinny triangles. And you can see they don't look congruent because we didn't draw the picture perfectly. But we'd like to show they're congruent. And how are we going to show they're congruent?
Well, we need a congruency theorem.
Okay.
We can do side, angle, side.
Alright, how's that going to help?
Because we drew this side in.
Okay. What can you tell me about this side?
Well, it's the diagonal on the square.
It's the diagonal of the square, and all these squares are the same.
Yeah, so
this side, that side, and that side are the same. Great. So now we know this diagonal of the square is the same in all three of those triangles. Okay, so I'll mark it with a tick mark. Alright, what else is the same?
So now we need to find out if the angles are the same.
Okay, so this angle here,
Yep.
that angle here, and that angle there. Alright, before we do that though, let's get the other side. What's the other side? What can we say?
Well, it's a side of the square, so they're the same.
Perfect, it's the side of a square. And right here. Okay, so we have side are the same in all those triangles. And now if we can just show the angles the same in all those triangles, we will be great, right? Because we'll have side, angle, side, and all three of those skinny triangles will be congruent.
Well, we have two smaller angles.
Okay, we have each of the big angles we're trying to show has two pieces to it. One piece is inside of the square here, and one piece is outside of it. Okay. Which one of those angles do you want to talk about first?
Let's talk about the inside one first.
Okay. Inside the square, what can you tell me about that angle?
Well, I think it's going to have some other angles that are equal to it.
Okay, that's true. It will.
And this diagonal bisects this angle.
Oh, interesting. How come?
Because there's only one diagonal that can go from. There's only one possible line that can go to 2 points.
Okay, so in a square, the diagonal bisects the angle. And the reason is you've got two triangles that are the same here, so the angles correspond to each other. That's not true in a rectangle. Oops. If you can imagine drawing a rectangle properly. In a rectangle, the diagonal does not bisect the angle. But in a square, it does. So what can you tell me about that angle?
It's 45 degrees.
45 degrees.
And all the other inside angles are.
All the angles inside the square are 45 degrees. So that's pretty nice, right?
Yep.
Okay, now this outside angle is an interesting one to try to understand. What can we say about that angle?
Well, it doesn't look like it would be 60 yet.
Doesn't look like it's 60 now.
Well, Could it be 90? Those are the two squares.
Okay, well, why don't you draw, let's use this one up here just because it's in the center of the board. Why don't you draw the angles that you know for sure are 90-degree angles?
Well, this one
Okay,
and that one.
all right, so you know for sure, so could this one be 90? What would that mean if that was 90?
Well, I mean this one was 90.
Okay, is that 90?
No, this
No.
is 60.
That's 60.
So this is going to have to be 120.
How come?
Because this there's angles in a circle add up to be, angles in that full circle is 360.
Okay, very good. So we had a 45-degree angle and a 120-degree angle. So that's a 165-degree angle right there.
Yep, and then all the other ones correspond.
And there and there. So, what did we just show?
That this is an equilateral triangle.
Okay, and why is that an equilateral triangle?
Because all three sides are the same.
All three sides are the same because we found side, angle, 165 degrees, side. So, probably this is the triangle we drew correctly because 165 is almost 180, right?
Yeah.
Yeah. Okay, cool. So now, good job. Good job walking through that. That's a tricky proof. That's why this is a challenge problem. And now I'm going to show you two really cool theorems, actually. Okay?
Alright.